Hi, it's Darren DeNeve, Carlinville math team, and we're making some videos regarding some math team problems. One of the things that we've done in the other videos that we've made is to just provide a little mathematical tidbit. And today, I just thought maybe it would be good to just talk a little mental arithmetic. And so this came up in class today, and yeah, I think it's kind of a lost art. Maybe we'll do some more of these tidbits with mental arithmetic as we go along. But like if you have to multiply 35 times 18 or 45 times 22 or 35 times 12 and you'd like to do it quickly in your head, one strategy to use, and there's different mental arithmetic strategies, but one strategy you can use sometimes, especially with these that end in 5, is to double one of them and halve the other. And so 35 times 18 is the same as 70 times 9, which is easily calculated to be 630. And 45 times 22, you double one and halve the other. And so that's 90 times 11. And so that's 990. And 35 times 12 in a similar way is 70 times 6, which is 420. Okay. And so I just thought you might like to talk about that. Okay. So now we've got ourselves a math team situation, and it says find the, or let S equal, we're doing number 3. Let S be the sum of the solutions when 2x squared plus 5x plus 3 is 0, and let P be the product of the solutions for when 2x squared plus 5x plus 3 is 0. Now, there's a faster way to do this. This is a common math team situation, but if you didn't know the little trick, I'm sure it's possible that you would try to factor and you would be successful here. And so your answers are negative 3 halves and negative 1. And so those are your roots. And so then it says, well, what's the sum of the solutions and the product of the solutions times 4? And so the sum of the solutions would be negative 3 halves plus negative 1. That's negative 2.5. The product of the solutions would be negative 3 halves times negative 1, which is positive 3 halves. And then the question asks you for 4 times S times P. And so that's 4 times negative 5 halves times 3 halves. And so that's negative 15. Okay. Now that's a wonderful solution and a good way of doing it. However, if the answers weren't as easily found here, maybe they would give you some with some irrational solutions. You might want to have a better way of doing this. And so let's talk about that. And so 2x squared plus 5x plus 3 is 0 is in the form ax squared plus bx plus c to be 0. And so you might recall by the quadratic formula that x is the opposite of b plus or minus b squared minus 4ac all over 2a. Now, I just bring this up to just sort of talk about it. This is negative b over 2a, if I wrote it this way, plus or minus the square root of b squared minus 4ac over 2a. And so this is negative b over 2a plus this, and then negative b over 2a minus this. And so maybe you could see that the sum of the solutions, they're calling S, is negative b over 2a plus negative b over 2a. And so that works out to be the opposite of b over a. And so this is just a good little math team thing to memorize, that the sum of the solutions in a quadratic equation is the opposite of b over a. In a similar way, the product of the solutions, which they're calling p, works out to be c over a. And so if you multiplied these two things together, they're conjugates of each other. Negative b over 2a plus this thing, and then negative b over 2a minus this thing. It might be worth your time to actually pause the video and multiply that out, as a difference of squares. But you would end up getting c over a after you did a little algebra. Okay, and so what we're saying here now, to answer the question fast, if you knew these two facts going in, that you would be able to say, oh, the sum is the opposite of B over A, that's negative 5 halves, and then the product is C over A, that's 3 halves, okay? And then we already did the rest of the question. It wanted 4 times the sum times the product, and so, of course, the answer is still negative 15. All right, so that was the algebra question of the day. All right, here we go. Let's find what they want us to do in geometry, question 3. In geometry, looks like we've got a parallel line situation and some angles. It says that angle 1 is 2x plus 60. Angle 2 is 3x minus 90. So, they're all, we got parallel lines going. And so you could reason, for example, that angle 2 is congruent to this one that I'm pointing at. And then it's supplementary to this one. And then this one and this one are the same. And so what we could do with just a little geometry here is determine that those two angles are in fact supplementary. And so 2x plus 60 plus 3x minus 90 is 180. And then this becomes like a little bit of an algebra problem here. 5x minus 30 is 180. 5x is 210. X ends up to be 42. And then let's make sure that we're finding the question. Then it says find the difference between angle 1 and angle 2. And so angle 1, its measure is 2x plus 60, so that's 2 times 42 plus 60. And the measure of angle 2 is 3x minus 90, so 3 times 42 minus 90. And we want the difference of these, okay? And so we could do all this math if we wanted to, but we could also just sort of notice that we have 2 times 42 minus 3 times 42, so that's a negative 42. And then we have 60 minus negative 90, and so that's plus 150. So that works out to be 108. Now, I might have gotten there a little different than you would have gotten there. And, of course, you can use your calculator on this portion of the test, and so that would be fine to do that as well. All right. Let's move on to the Algebra 2, question 3. Algebra 2, question 3 says, let's see, for positive integers k and w, we have the cubed root of 9 times the fourth root of 16 times the sixth root of 36. And we want to write that as k times the cubed root of w. Okay, so when you get questions like this in math team, it's pretty common for you to want to say 9. The cubed root of 9 would be 9 to the 1/3 power. And the fourth root of 16, we may as well just call that 2. And the sixth root of 36, let's just go ahead and write that as 36 to the 1/6 now. Then we can kind of break this down. 9 is 3 squared. And so this is 3 to the 2/3 times 2. And then 36, follow me here, is 6 squared. And so, 6 squared to the 1/6 is 6 to the 1/3. And so we would want to rewrite this as 6 to the 1/3. And this is all a good thing here because we want to have it to the 1/3 power anyway. And so let's see where this all takes us. Okay. And so, 6 to the 1/3, and you might say, oh yeah, look, there's 2's and 3's. And so we have 3 to the 2/3 times 2, but then we're going to write this as 2 to the 1/3 times 3 to the 1/3. And so when we put this all together, 3 to the 2/3 times 3 to the 1/3, that's 3 to the 1st. And then 2 to the 1st times 2 to the 1/3. Okay. In fact, let's just keep it this way. So this is 2 times the cubed root of 2. And the reason we do that is because we're keeping in mind how they wanted our answer to begin with. And so this is 6 times the cubed root of 2. And then, in math team, they sort of ask you how to leave your answer sometimes. We're supposed to determine the sum k and w. Well, k is 6 and w is 2. And so k plus w is 8. If I haven't said this on this particular video, I need to say it every time. The idea here is that you might want to practice these problems on your own, right? I present you the problem, you pause the video, try to get the answer. Maybe you can get it, and then see how I solve it and see if either of us have similar thoughts. Okay, on the pre-calculus one, we have a tic-tac-toe question. As a side note, you should never ever lose at tic-tac-toe unless you're trying to. Like maybe you want to, give your 8-year-old little sister a little confidence. That's fine, but there is no reason for anyone ever to lose at tic-tac-toe if they're trying. And so you figure that out on your own if you're like, all right, now let's back to the question here. A man was doodling on a tic-tac-toe board with 9 boxes. He chooses 3 different boxes at random to make his doodles. Determine the probability that those boxes correspond to a winning path. And so, all right, let's see. So how many different ways can you win at tic-tac-toe? Well, there's 3 ways to win across, and 3 ways to win up and down, and 2 diagonals. And so there's 8 winning paths. And so then the next question becomes, well, how many ways can you put 3 doodles in 9 boxes? And so that answer is a combination where you choose 3 from 9. And so, you can do this on your calculator. Sometimes where's the fun in that? But you choose 3 from 9, and then this would be 9 times 8 times 7 divided by 3 times 2. And so that would be 84. And so there was 8 winning paths, and then there was 84 ways to just pick 3 boxes from 9. And so we want the probability, and so that would be 8 out of 84 in simplest form. That would be 2 out of 21. All right, there was your math teamwork of the day. Hope you enjoyed it. See you next time right here in room 261.